Hello, welcome everyone. Today we are on day 7 of 21 days free GCSE crash course. It was a bit delay in between that because I started uploading the past paper questions, so that's why I took a break from the revision of each topic. Now from today I'm again back to uploading the same. That means revision on each topic, and today I have picked the topic probability. So in probability, in GCS, you will see its probability tree diagram specifically, and you will see in the last sections where the marks are like 5 markers. So you will see that generally you will find the questions on probability, vectors, circle theorems, the harder questions on that. So this is the reason I think probability tree diagram is one of the most important topic, and we should do that one. But before I move on to the probability tree diagram, it's for those who are not aware of the probability or who just forgot about the basic concepts of probability. So I'm just brushing it up first, and then we'll move on to the tree diagrams. So in this lecture, I'll be doing the basics of everything. And if you are pretty much good in your basics, so you can skip this video. But in between that, I'll be sharing few tips so you can like definitely go through it. And if you're running out of time, so you can pick my second video on probability. There I'll be doing some harder questions on it. So let me start with this video. First, I'm starting with the definition of probability. Probability is the chance of something to happen, the possibility of something to happen. So definitely, like if somebody asks you like what is the probability that it will rain, okay, suppose you have some plan of going outside and it's a rainy season, so you have to at least predict or you will talk about that. So basically what you're talking about the chances of raining. So similarly in mathematics we are talking about the chances of any event to occur, and that's called probability. In general language we don't use the numbers, like instead we use the words okay, probable, equal, it can happen, it may not happen, something like that. Even you can, if you use the numbers, you will say 50-50% chance, that's the maximum. 100, 0, 50, that's the maximum that you can use. But in mathematics when we talk about the probability, we are talking about the specific numbers. That means 0.752, like a very precise numbers. And for that we have formula as well to calculate. So I'm starting with the basic definition. I'm writing up here. So it's a chance of something to happen. Now let me see a probability scale, because as I told you, probability in mathematics we give by the numbers. So definitely there should be a scaling by which we can get to know that what is the value. And to understand the scale, you should know that the value of probability lie between 0 to 1. So there is only value between 0 to 1. So say for example you have calculated a value of probability and it comes out to be 1. So ultimately it will give you an indication that suppose if your value is going to be greater than 1 or lesser than 0, it's a wrong answer. So probability values lie between 0 to 1, and this is a scale, the probability scale, where here it's 0, at the mid it's 50%, and here it's 100. In terms of percentage it would be like this, and in terms of number it would be 0, 0 0.5 and 1. 0, that means no chance at all. If I say that the Monday will come after Thursday, so there is no chance that it could happen. So I can say that Monday cannot occur after Thursday. So probability of Monday to come after Thursday. Now if I talk about what will be my answer when I flip a coin and I'll get a tail. What will be the probability that when I flip a coin and I'll get a tail? So there are 50-50% chances. Obviously when you flip a coin you can expect either head or tail. So there are 50-50% chances. So where you can say equally likely. So it would be probability of getting a coin, getting a head on flipping a coin. For the 100%, when you are pretty sure about something, and that can be if I say that March will come after February and it's 100%. So that means when you are sure and 100% chance of something to happen, and the such examples are if I say that March come after after February. So this is about the scaling of probability. Now let me move on to the formula to calculate it. So formula to calculate, there are few terms that you should understand. When I'm talking about probability of something to happen, here I'm saying the number of chances by which an event can occur. The number of chances or number of ways by which an event can occur over the total possible outcome. Now in this formula, the first important thing is you have to see the number of ways by which an event can occur. Event, what is that event? Or there is, suppose there is an experiment. Now you would be thinking, what is experiment? Whatever the value, whatever the thing that I'm doing, say for example I'm flipping a coin, so that would be my experiment. Not necessarily experiment is always done in the laboratories. It's only whatever you are doing and for which you are reading, or you want to know the outcomes, the result, something that you are studying. You're doing practical for it, and that would be your experiment. So if you want to know the probability of heads, what will be the probability of head, or what will be the probability of getting tail, probability of getting one on a dice, so in that case either you are flipping a coin, you're rolling a dice, that would be your experiment. Event, that means all the possible ways are your event. Actually the events are, suppose I'm flipping a coin, so I'm flipping a coin, I can get either head or I can get tail. So head is one of the event, tail is one of the event. When I'm rolling a dice, a six-sided dice, I can get 1, 2, 3, 4, 5, 6. I can get these 6 numbers. So these 6 numbers are the events of this one. That means you can say outcomes. So outcome would be event, but specifically I use event for that word for which we are calculating the probability. Obviously, probability of head, now this would be one event. Probability of tail would be one event. These are outcome. When you are rolling a dice, you will get 1, 2, 3, 4, 5, 6 as the value. When you are calculating the probability, the same thing you can use the word as event. They will become your events. So, the number of ways by which an event can occur. Suppose the question is, on flipping a coin, what's the probability of getting a tail? So if I use the same formula, the number of ways by which an event can occur, how many ways by which I can get a tail? When I flip a coin, it has 2 sides, one tail and one heads. That means I can get one tail. So probability is, or the ways by which I can get tail is 1 over total possible outcomes. I can get either heads or tail. So there are 2 possible ways. So 1 over 2. So probability of getting a tail would be half, and similarly I can say probability of getting head would be same. I can get one head out of 2 total values, that is out of heads and tails. This is the way by which you can calculate the probability. Let's say one question. Say this one. This question says a bag has 20 balls, 4 green, 6 red, and rest of the balls are pink. A man has picked one ball from the bag. What is the probability that he has picked a pink ball? What's the probability that he has picked a pink ball? First is, because our event now is picking the pink ball, so only we need to focus on pink, that how many ways by which I can get pink. So how many pink balls are there? Total there are 20. 4 are green, 6 are red, and remaining are pink. That means 10 are pinks. So if you want to pick pink ball, there are 10 balls there, so he can pick any one of them. So he has 10 choices, he can pick any one of them over total possible outcome. If a bag has 20 balls, he can pick any ball. Now I'm not specific to the pink ball only, I'm talking about the total number of balls, that would be 20. So picking a pink ball is half in this case. Similarly for part B, it says he has picked a green ball. For a green ball, how many green balls are there? There are 4 green balls. That means he has 4 choices, or number of ways by which he can pick green is 4. Over total possible ways by which he can do, that means he can pick any ball from those 20. So total possible ways are 20. So probability is 1 over 5. This is the way by which you can calculate a probability. Now there is a concept of and or. The word and or. If you see these two words, what you have to do, suppose they are asking you find the probability of this and this. Whenever you read the word and, you have to multiply immediately. And when you read the word or, that means what's the probability that this will happen or this will happen. That the chances like either can happen in that case. If you see or word, you need to add the probability. You have to calculate like this. Now, that we do one question so that we can get a better understanding of it. Now, this says that this is the same question that we just did. Only the parts have changed. It says the bag has the same 20 balls, 4 are green, 6 are red, and remaining pink. That means 10 are pink. And a man has picked one ball. Then that he will pick red and a green ball. I just explained you the concept of and. If there is an and in between, you are supposed to multiply. That means probability of finding green and probability of picking red. If there is n in between, if there is an n in between, we need to multiply them together. So probability of picking green multiplied by probability of picking red. What's the probability of picking green? There are 4 green balls out of 20. So 4 over 20. Into picking red, how many red balls are? 6 out of 20. If you simplify it, you'll get 2 over 1 over 5 times 3 over 10, which is 3 over 50 is the probability. Moving on to the second one, that he will pick either pink or red ball. Now there is or. If you got confused, the best way is you just write down in a word, in a sentence, that would give you a better clarification of how to solve it. So that he will pick either pink or red, that means probability of picking pink or probability of picking red. Probability of picking pink is, how many pink balls are there? 10 out of 20. And or means add them up. Probability of picking red is how many? 6 out of 20. Answer is 16 over 20. If you simplify it, it will give you 4 over 5. That's the probability. Now, if he is picking 2 balls, if on picking 2 balls, find the probability that he will pick both red balls. We have to calculate the probability that he is picking both the red balls. So, probability of picking red ball and red ball. See, both means add. Sometimes students get confused what is the meaning of both. Both is like what we are supposed to do in case of both. Both is nothing, it's add. So, probability of picking red and picking red. Now the difference is he's picking 2 balls. That means he will pick one by one. So if he has picked one ball for the first time, then again he is picking. So there will be a little difference. Probability will not remain same because one event is dependent on another event. These two are called dependent events. When happening of one event can cause an impact, can lay an impact on other one, can cause a change to another one, then we say they both are dependent variables or dependent events. But when the occurring of one has nothing to do with the second one, there is no impact, then we would say it would be an independent event. Just like I'm rolling a dice and flipping a coin. So what is the probability that I'm flipping a coin 1 time, 2 time and rolling a dice? That means simply if I'm rolling a dice, it's a simple whole different thing. On getting number 1 doesn't change my probability on coin. So these two are independent events. Whereas in this case, if I'm picking a ball from a bag, it can change. How? Let me see so that I can understand. Like after this question, you will be able to understand it more properly. What are dependent events? That he will pick both the red balls. In the first case, there were 20 balls and he picked red balls. There were 6 red balls. This is the initial amount. Initially, the red number of balls are 6 and total number of balls are 20. So, probability of picking red ball would be 6 over 20. And after the second, this is what the second chance, because he is picking the second pick, or more probably I would write second pick. Now when he is picking the second number of time, then how many number of red balls are there? This is initially, that is the first pick. In the second pick, how many red balls are remaining? He has already picked one red ball. So the number of red balls remaining are now 5. That you have to understand. And now you would understand that the probability of picking the red ball second time has changed. And when the probability has changed, that means they are dependent variables, dependent events. So total number of balls remaining are just 19 because he has already picked one ball, that was red ball. So what's the probability of picking red ball second time? There are 5 red balls out of 90. So it will be 30 over 380, or simple 3 over 38 is the probability of picking both the red balls. We'll pick both the balls of same color. Both the balls of same color. First, for such questions, let we write down in, you can say, in an English sentence way, so that we can get a better idea. It says he will pick both the balls of same color. That means what's the probability? Probability that he can pick red red, he can pick green green, and he can pick pink pink. Now probability of red red, see, he can pick only one combination. Either it will be only red red, because both balls should be of same color. So either it will be red red, or it will be green green, or it will be pink pink. These are the possible combinations. As I told you, if there is or in between it, you need to add them up. So probability of picking red and picking red, or is going to be probability of picking green and green, or probability of picking pink and pink. These are the possible ways. We just saw that they are dependent variables. So probability there were 6 red balls out of 20. And how many red balls after picking it? It would be, remaining would be how many? 5 red balls out of 19. Plus, or means plus. Green balls, how many green balls were there? There are 4 green balls. So you are picking 4 green balls out of, and how many remaining balls are there? 3 out of 19. Plus, how many pink balls were there? There were 10 pink balls out of 20. And in the second pick, definitely the remaining would be 9 over 19. So it would be 30 over 380 plus 12 over 380 plus 90 over 380. So this will give you 132 over 380. We can simplify it or leave it like that. That's totally fine. So this is how you can calculate it. For such questions that we just did, the last one, for such type of questions, we actually refer the probability tree diagram. So that we will be discussing. But before discussing probability tree diagram, there is one important thing, and that is a equation which you have to keep in mind. It says sum of the probability of all the events of a given experiment is equals to 1. Now let me understand what exactly the meaning of the sentence. It means, suppose I'm flipping a coin. Let's take the simplest example. I'm flipping a coin. So when I'm flipping a coin, I can expect either to get tail or head. Either tail or head. So what my events are? Tails or head. Probability of each event. Probability of tail plus probability of head. That's the sentence. The sum of probabilities of all events. All events, that means when I'm flipping a coin, I can expect to get tail and head. Nothing else. Is equals to 1. And we have just seen the probability of heads is half, tails is half, sum is 1. Similarly, when I am rolling a dice. So rolling a dice, on rolling a dice, I can get 1, 2, 3, 4, 5 for a 6-sided dice. So probability of getting 1 plus probability of getting 2, that means sum of all probabilities of all events. When you are rolling a dice, you can expect 1, 2, 3, 4, 5, 6, not more than that for a 6-sided dice. So probability of 3 plus probability of 4 plus 5 plus 6, it should be equals to 1. That's the meaning of sum of all probabilities. So sentence means sum of all probabilities of all event of an given experiment, event of a given experiment is always equals to 1. And we just so you know that what's the probability of getting 1 when you rolling on by 6-sided dice? It's 1 by 6. For 2 is also 1 by 6. For 3 is also 1 by 6. For 4 is always 1 by 6. 1 by 6. 1 by 6. If you add them up, you will get 1 as the answer. Now, let me move on to probability tree diagram. This is the important thing that we will be doing in GCSEs, the harder questions you will find from this part. So, title is probability tree diagram. Here it's kind of tree, that means different branches are there that are connected and will lead to the next possible outcome. So that is there in probability diagram, and that we can clear that we can get a better clarification once we have a question with us. It says in a bag there are 20 balls, 12 are red, 12 are green, and rest are brown balls. If a man has picked 2 balls, then draw a probability tree diagram. That means what all possible ways are there of picking the 2 balls. First thing is he is picking 2 balls. That means there are 2 picks here. Picks, that means first pick and second pick. First pick and second pick, because he would be having different ways of picking the ball in first pick as well as for the second pick. For the first pick, he will have, because there are only 2 colored balls are there, either green or brown. So either he can pick green or he can pick brown. These are the 2 possible ways by which he can pick. There's no other way. So probability of picking green ball is, how many green balls are there? 12 out of 20. And of picking brown balls, how many rest are the brown balls? That means 6 are brown balls. So 6 out of 20. Besides it, the same branches that are leading to different directions, that means this and this, their sum should always be equals to 1. Always. Here also 12 over 60 or 20 plus 6 over 20 will give you 1. Now if he has, in the first pick, he has already picked 1. Let me write this down. This one is green and this one is brown. Suppose he has already picked 1 green ball, then there are 2 possible ways, 1 and 2, by which he can pick the other balls. That means in the second chance, again he will be having 2 different ways. For picking blue and this, he will be having 2 different ways. So what I'm saying, if in the first pick he has already picked 1 green ball, again he'll be having 2 different choices. Either he can pick green ball or he can pick brown ball. Because he has already picked 1 green ball, how many green balls are remaining? 11 green balls are remaining out of 19. Then for brown, in the first pick he hasn't picked the brown one, right? Okay, because I'm talking about only this case. So in the first pick he has picked green balls, so the number of brown balls remain intact. That means number of brown balls are 8 over, I'm sorry, I wrote 6 here, it's 8. So number of brown balls are 8 out of 19, because 1 green ball he has already picked it. For the second one, say for example, the second one he has already picked brown, then what are the remaining number of balls are for the green and brown, because for the second pick again he'll be having 2 different choices. Either he can pick green or he can pick brown. Because he has already picked 1 brown, so the number of green balls remains same exactly, which is 12, but the number of balls are 1 less now, which is 19. If he has already picked brown, number of browns are 7 and remaining are over 19. This is the probability tree diagram. We have to show all the possible ways and the 2 events that are occurring consecutively. The question is, find the probability that both balls will be brown. Both ball will be brown, that means brown from the first pick and brown from the second pick. So we have to select this branch. Brown, he is picking brown in the first pick and leading to another brown in the second pick. That is, probability is 8 over 20 into 7 over 19. So it would be, so we have to do 8 over 20 into 7 over 19. That will be our total possible combination when he's selecting both balls will be brown. Next is find the property that the man picked ball of different colors. For different colors, he will be having a combination of picking. He can pick first green and then brown, or he can pick first brown and then green. These are the two possible ways. Okay, he said the question is only that two of different colors. Different colors are green and brown, but the arrangement is not mentioned. Like first he's picking which and second he's picking which. So we have to consider them that either he can pick first green and blue, or he can pick brown or blue green. That means simple, the combinations are there, two different ways. So first green and then blue, first green and sorry brown and then brown. That means 12 over 20 into 8 over 19. So 12 over 20 into 8 over 19, and or represents plus first brown, that means 8 over 20, and then green, which is 12 over 19. So that means 8 over 20 into 12 over 19. This will give you the ways by which the man can pick the balls of different color. Let me do one more question on it. It says probability of winning a chess game is 0.3 and probability of losing a badminton game is 0.7. If a man plays both the games, find the probability that he will win both the games. So first, that means for the first game and for the second game, let me make the two columns. First game is, let me take for chess. First game is for chess. If he plays a chess game, either he will win or he will lose. We have to consider all the possibilities. So obviously if he is going to play it, either he is going to win or he is going to lose. If he will win it, that means probability of winning chess, this one is for chess and this one is for badminton. If he wins it, it will be 0.3. If he will lose it, it will be 1 minus 0.3, which is 0.7. So losing chess will be 0.7. If he has already played chess, then for badminton, because he's playing both the games, that's important. He doesn't have choice that he will play chess or he will not play chess. Okay, so he's definitely going to win. So the definitely will be on the two columns. If you are confused that what two things I should place in the column, so two definite things that are going to happen. So he played those, so that's why the two columns would be first one for chess and second one for the badminton. Now, he will be having two different possibilities. Either he will win badminton or he'll lose badminton. For losing badminton, probability is 0.7. That means for winning, it would be 0.3. And same can be said that if he has lost the first chess game, still he will definitely going to play the badminton, but either he will win badminton or he will lose badminton. And so this is 0.3 and this is 0.7. So this is your tree diagram. Now let me do the question that they asked you. Find the probability that he will win both the games. He will win both the games. That means what I have to do? Win both games. That means he will win chess and he will win badminton. So I will choose winning chess and leading to winning badminton. So 0.3 times 0.3, that will be 0.09. This is the probability of winning both the games. Second is find the probability that he will lose exactly one game. He will lose exactly one game. That means because he is definitely playing both. So the case can be that he won first but he lost badminton, or he won badminton but he lost and he lost chess. Sorry, here, but first was chess. So we can say losing chess and winning badminton. So winning chess and losing badminton, because this branch is leading me to this branch obviously, so I'll pick that. So winning chess is 0.3 and losing badminton is 0.7, or that means add them up, he can lose chess. So losing chess is 0.7 into winning badminton, which is 0.3. So that will be 0.21 plus 0.21, which will give you 0.42. This is the probability of winning exactly one game. So that's it for today. In this video, I have cleared you the basics of the probability, and in the next class, we'll be doing some harder questions as well as the worksheet on probability. I have already uploaded one worksheet on probability that are on my earlier videos. If you want to refer, you can refer that as well. And if you want to access the free worksheets, it's there on www.akziacademy.com. You can access that, and if you are an Android user, you can avail that on Play Store. Akzsi app is there and you can get the free resources. And apart from that, I say that in my every video that I'm running GCSE crash course batches. So if you want to book a demo, just email us at akziacademy@gmail.com, as well as if you're looking for just doubt sessions, only doubt sessions, that if you have a doubt in particular questions, so you can book a 1 hour session with us. Like, not necessarily you need to continue, or just 1 hour session would be enough. If you think like it's 2-3 hour you require, you can do that one. Just drop us an email at akziacademy@gmail.com. So that's it for today. Thank you. Have a great day. Bye.